Once you have a good understanding of correlation and scatter plots, the next thing that you want to start to do is figure out how the line of best fit is created. In our case, the regression line or the least squares regression line. So I've got a scatter plot here with a moderate positive linear association. And what we could do is we could try to draw our own line of best fit. And if you were doing this just using your eyes and making a rough estimate, you would try to balance, just kind of like we do with the mean and median in the first chapter, about half of the points on one side and about half of the points on the other, assuming that there's no strange outliers or anything like that to really impact your decisions here. So we've got about 10 points, so about 5 points on one side and 5 points on the other, and obviously you can have some points right on the line. So you could keep messing with this until your predictions seem to be more and more accurate. But obviously we have technology to help us here. So one thing that we can do on our own is calculate residuals, and they work like our deviations that we worked with in our original chapter. Now, I guess the best way to look at residuals is to compare them to the actual line of best fit here. So this is the actual line. So we know residuals are comparing our actual data to the observed data from the prediction line. So about half of your residuals will be positive and half will be negative. And the problem that comes up with that is the same problem we had with standard deviation. When you take the sum of these values, the sum will always be 0. Okay, so the same kind of steps that we went through in the standard deviation topic will go through again here. In order to alleviate that problem, instead of just taking the residuals or the deviations on their own, we square them. Okay, so I've got another applet that shows kind of like what that looks like. So we continue to manipulate our slope and y-intercept, and you can see when I square the values, the different sizes change. Now my goal as I keep adjusting these values is to minimize the squares, the area of the squares. So the sum of the squares is what we want to minimize in order to come up with the best line of fit. Okay, so the actual one here, I'll click on that, would be that kind of slope. So it's not easy to do just by guessing and checking, but you could have a tool like this where you're looking at the visual areas, and I'll try to match things up here so we can see here that when I do this, the squares become smaller and smaller and smaller. Hopefully I can match it up pretty well. Okay, so that is our goal, to minimize the sum of the square area for all of the points, and that will be our line of best fit. Okay, so that's what we're working towards. Obviously there's technology that we'll use there because there's a lot of options, and it gets into some calculus which we don't need, like limits and things like that, but we just want to know what the calculator is actually doing. Okay, one last piece of information before we go on and practice some of this stuff is you need to know that each regression line, once the calculator finds the best one, does in fact contain the point that is the mean of x and the mean of y. So no matter what or how many points I add to this or how I adjust this, even if there's outliers, the mean of x and the mean of y will always be on my line of best fit. Okay, so keep that in mind as we go forward. I'll also, as the week goes on, show you how the standard deviation of x and standard deviation of y come into play when we calculate our slope of this line of best fit. Okay, so thanks for watching, and we'll continue adding more details as the week goes on. Thanks a lot.